I grew up in a company town, built upon a single industry which one autumn day during my childhood simply ceased to be. Antibiotics had arrived, almost overnight, rendering the fresh air cure completely irrelevant. The nurses and doctors were summoned, my grandfather gave a short speech, and then the cottages were boarded up, the wide porches with the magnificent views abandoned to the season's early snows. A photographer from Life came up to document the occasion, but he accidentally exposed his film in the sanatorium's X-ray lab. By then, the patients were gone, and with them a way of life. All that remained were tales of the countless consumptives who for 70 years had traveled to this hushed, gentle place to regain their health, and most of these would soon be forgotten.
In 1884, E.L. Trudeau built the first cure cottage as a new mode of treatment for tuberculosis in the United States. 10 years later, he built the first research laboratory for the study of TB. Nearly a century later, his grandson, Francis B. Trudeau, Jr., founded Trudeau Institute for Biomedical Research in 1964. Trudeau Institute is the only independent, not-for-profit research center totally focused on the study of immunology and infectious disease. Classical vaccines have eliminated scourges such as smallpox, but many diseases have not yielded to the classical approach. Trudeau is on the forefront of the challenge to develop a new generation of cures. Led by a world-renowned immunologist, Dr. Susan Swain, Trudeau Institute has assembled outstanding immunologists, cell biologists, virologists, and infectious disease specialists. These scientists dedicate every day to understanding how to improve the power of our immune system. Trudeau scientists have identified the component of the immune system that makes it difficult for older people to fight infection, even after they've been vaccinated.
As people get older and as animals get older, their immune system doesn't work as well. And what we found is this is mainly due to a specific population of lymphocytes called helper T cells. And what we're trying to do is figure out exactly what the defect is, and then how do you go about correcting it. And I think that my work has been very novel in defining what these defects are. What we're trying to do is see how we can make vaccines work better so that we can boost the function of the lymphocytes in the older people so that they have better protection when they get their immunizations.
5 million people die from flu, pneumonia, and other respiratory diseases each year.
We know that the immune system has a number of weapons that it uses against infectious diseases, and one of these weapons is the white blood cell. And we've been working at trying to understand how that white blood cell actually targets infectious disease and how it works to clear that infectious disease. And I think the biggest contribution that my lab has made is in showing that these white blood cells are actually present in the lung before an infection comes along. In other words, they're sitting there waiting for that infection so that they can respond immediately. And this is an important observation because what we've realized is that many modern vaccines don't generate these types of white blood cells, and they certainly don't generate them in the lung. Modern vaccines are not optimally suited for protecting people against what we call respiratory infections. The presence of these white blood cells in the lung is going to be of tremendous value for the development of future vaccines because we can now figure out ways to get these cells to the right place at the right time.
Trudeau scientists collaborate in weekly journal clubs, chalk talks, and lab meetings to discuss their research findings. Trudeau's work is the foundation upon which other researchers build for drug discoveries. Guest speakers present and discuss their research in the Founders Library at Trudeau Institute. In addition to attending our in-house seminars, our scientists travel throughout the year to attend various seminars and conferences to broaden their findings. Trudeau scientists have shown that the immune responses can be started in the lung, which leads to developing approaches to vaccinate the lung.
And the reason why this is important is where an immune response starts dictates how it will proceed. So if an immune response starts in the nose, it might do one thing. If it starts in the lung, it might do something different. So it's important not only for the course of disease, but for developing vaccines, because we might want to make a vaccine that initiates an immune response in a particular location.
Trudeau scientists have identified a molecule within the immune system that turns off an overactive immune response.
The ability of interferon gamma to serve as a molecule that both initiates and suppresses inflammation obviously leads to a lot of complexity. But if we can harness the aspect of the molecule that suppresses inflammation, this could form the basis for an effective treatment for autoimmune diseases such as multiple sclerosis.
The mission of the Trudeau Institute is to study how the immune system combats infectious disease and cancer. Our goal is to figure out the mechanisms by which the immune system can do these things so that we can learn how to make more effective vaccines and therapies which enhance immunity. Millions of people die each year, at least 7 million worldwide, from cancer and from major infectious diseases. And many of these diseases have the potential to be eradicated by appropriate vaccines.
Most vaccines have been evaluated for their ability to induce antibodies, one component of immunity. Trudeau scientists have found that we need to induce other components of the immune system for broader immunity against many strains of virus.
We have identified some of the components of the immune system that are absolutely essential for controlling either infectious disease or tumors of the lung. And by understanding what these components are, we can take advantage of that information to make better vaccines. And the other thing we can do is we can understand why sometimes vaccines don't work very effectively, because we can understand that some of these components of the immune system may give inappropriate type responses.
Trudeau scientists have defined how immunological memory can help cells fight more effectively when an infection invades the body for a second time.
When you are initially immunized against a pathogen, or if you've been infected with a particular pathogen, your immune system remembers this, and therefore the second time you encounter this pathogen, you don't get as ill, or you don't get ill at all.
3 million people die each year from tuberculosis, and 1 million people die from HIV/AIDS-related infections. Trudeau scientists are identifying components of the immune system that begin to explain why people get tuberculosis. This is especially important since immunocompromised people, those with HIV/AIDS, or those undergoing specific kinds of chemotherapy, for example,